All right, so when you were taking your test today, and as you finished, I gave you a worksheet that the top 10 questions had numbers to plug in. And those numbers that you plugged in actually gave you a numerical answer like yesterday's notes. Now I'm going to the next type question that's on that worksheet, which is about compositions without letters. And I really would have rather taught some other questions before this, but these are easier and short, so I can get this in with what time I have left. Are these functions inverses? For them to be inverses, I have to be able to use the commutative property with my inverse questions. Not all questions will allow you to do this. Only inverse functions will work with commutative. What does commutative mean? It can go either way. That f of g of x will give me the same answer as g of f of x. That is not true on all questions. That is only true if they're inverse functions of each other. Now, we haven't studied inverse functions yet, so this is kind of introducing what are inverse functions and how can you test for it. So I have two linear ones. They got a good chance. I mean, it wouldn't make sense that I'm going to say a linear and a quadratic are going to flip over each other and make each other the same, right? They're not even the same shape. So if I was asked that, I would know it's wrong already. But a quadratic and a square root might reflect over each other and be the same because they're inverse operations. But just because they look like they might have a chance doesn't mean it will always work. You got to have the right operations with the right numbers to make it work. So we're going to look at a composition of these two functions both ways. So let's start with f of g of x. We are going to put g inside of f where this x is. That means take out that x and put in an entire function for it. Put in g of x for x. That would be 1/2 x plus 10. Does everybody see what I did? I took out g of x and I put in what g of x represents. I don't have a number, I have an expression. Then I work this out. Half of that, well, half of 2 is 1. And 2 times 10 is 20, right? Everybody agree? Minus 5. Does it work? Well, I don't know. This side came out to be x plus 15. We'll see if the other side comes out to be x plus 15. So on this side, we're going to do the other way. We're going to do the problem by putting f inside of g. So we have 1/2 plus 10, and this big gaping hole here is going to represent the function f. We're taking 2x minus 5 and plugging it in the g function where the x was. Half of 2x is x. Well, that part matches. Half of -5 is -5/2. And when you add that to 10, I don't think that's going to make x plus 15. Do you? No. Because that's 2.5, and 2.5 from 10 is 7/2. So that's 15/2. Okay, I did a bunch of math in my head, but y'all could have figured that out if we just don't have the time to sit here and subtract all that on paper right this minute. What about us? Because that's 2.5 from 10, and that's 7/2. Because 7.5, 7.5. That's 7.5. So that's 15/2. 7.5, not 7/2, but 7 1/2. Maybe I should have said it that way better. So that's x plus 15/2. They are not equal, so no, they're not inverses. All right, we're going to look at another example, but before we do, I want to look at the numbers that I wrote on the paper to make sure I've got something that maybe works this time. I don't know. Let me double check it in my head. Yes, I think this one might work. All right, we'll see. Let's first try f of g of x. Let's put g inside of f. So we're going to say 1/3 with a big parentheses minus 2. That's the f function. We're going to put the g function inside of there with 3x plus 6. What's 1/3 of 3? 1. What's a third of 6? 6 divided by 3 is 2, right? Minus 2. 2 minus 2 is x. So if I make the other side come out to be x, then I have inverse functions. Does that make sense? Okay. So we're going to try it. We're going to see if the commutative property works. So we're going to take 3 with a big blank plus 6, and we're going to plug the f function in that parentheses. We're going to plug in 1/3 x minus 2. Again, 3 times a third is still 1x. 3 times 2 is going to be -6, plus 6 makes x. They're equal. Now here's another little hint. What does that represent? Well, if you graph these on your calculator, that would be one of my lines. This would be the other line. Eventually they cross somewhere down here. This x represents the line they reflected over. It always has to come out to be x. Or negative x, because they could reflect this way from quadrant 2 to 4 type look. This is a flip like over the quadrant 1-3 split. The whole top's coming down this way. It could split the other way and do it over negative x. But they have to match. And they have to be this is actually the equation of the line of symmetry in this problem, which we'll go into a lot more detail later on. But it always comes out x or negative x. So if they don't match, negative x is equal to negative x, or x equals x, it's not inverse. The commutative property has to work. Does that make sense?
So if you solve one side, you got 2x.
Then you know it's not going to work on the other side. But yes, because this is kind of like a proof. You're proving that it doesn't. Now, for those of you who take calculus next year, that's what I'm about ready to teach in my calculus class right now. We actually show an algebraic way to do it and a calculus way to do it. Sometimes the calculus way on things can be longer. Sometimes the calculus way is shorter than the algebraic method. And I think in this one it actually is shorter to do it with calculus than it is algebra. But that's the key to it. Some things are just, not going to be short. Compositions take a little bit of math, but not really hard math. Now, these were all linear, okay? Linear has to be compared to linear for it to even try. Quadratic has to be compared to square root to even try. Cube would have to be compared to cube root to even try. So if your two functions are not inverses of each other because of the type they are, you know it's no already, and there wouldn't be any reason to even work the question.
So we don't have to work with the
I mean, that wouldn't ever work, okay? So that's why normally when you look at questions like this, they're not probably going to ask you to do that, but in your homework there might be some like that just to give you a little bit of practice with working other functions. So on that worksheet I gave you earlier, there are 4 of these. And there are a couple of them that it's pretty obvious from the get-go it's not going to work. Look at number 1. Why does number 1 definitely look like it's not going to work? Exactly. But it's just going to give you a little bit of practice. It's also going to give you a little bit of practice of putting a quadratic in a linear and a linear in a quadratic, because that is important for compositions when you're not doing inverse work. And it would be great that you could practice that before you do the big questions that are on the last page that I'm going to teach on Monday. So you have 4 questions on this worksheet to do. You have your domain and range that you need to finish, plus these 4 questions. Okay? And then you have your study guide that needs to be turned in before you leave here today. It needs to be in the basket. Okay, is everybody okay? All right.